Discover the shocking story of the Clear Lake Volcanic Field, one of California's most dangerous volcanic systems that remains largely unknown to the public. Located just 144 miles from San Francisco, this volcanic complex is home to more than 17,000 residents and receives 70,000 annual visitors, all unaware that they live atop one of the state's greatest geological threats. In this revealing video, we explore how Mount Konocti and the Clear Lake Volcanic Field earned a high-threat classification from scientists, the specific dangers they pose, from pyroclastic flows to devastating lahars, and why volcanologists maintain constant vigilance over this seemingly tranquil region. The Clear Lake Volcanic Field wasn't always there. Like many of California's most dramatic geological features, it was born from violent processes that continue beneath the surface today. Located in Northern California's Lake County, about 144 miles north of San Francisco, this volcanic complex represents one of the most significant geological threats in the state. The field covers an area of roughly 400 square miles and includes multiple volcanic vents, lava flows, and geothermal features that tell the story of millions of years of volcanic activity. The volcanism in this region began approximately 2 million years ago, driven by the complex interactions of several tectonic forces. Unlike the Cascade Range volcanoes to the north, which are created by subduction of the oceanic plate beneath the continental plate, the Clear Lake volcanic system is associated with the broader tectonic activity of the San Andreas Fault System and the northward migration of the Mendocino Triple Junction. Mount Konocti, rising 4,300 feet above sea level and 2,700 feet above Clear Lake itself, is the most prominent feature of the volcanic field. This massive stratovolcano is actually composed of multiple overlapping volcanic cones that have built up over hundreds of thousands of years. The mountain's name comes from the Pomo Native American word meaning mountain woman, reflecting the deep cultural significance this landmark has held for indigenous peoples for thousands of years. The most recent volcanic eruptions in the Clear Lake area occurred roughly 11,000 years ago during the end of the last ice age. These eruptions created several volcanic features that are still visible today, including cinder cones, lava flows, and volcanic domes. The most prominent recent feature is Mount Konocti itself, though the mountain has been dormant for thousands of years. But dormant doesn't mean dead, and that's what makes the Clear Lake Volcanic Field so concerning to geologists. The field shows numerous signs of ongoing volcanic activity beneath the surface. The region is home to extensive geothermal systems, including hot springs and fumaroles that release volcanic gases. The most famous of these is Sulphur Bank Mine, where mercury was once extracted from volcanic deposits, and where visitors can still see steam vents and smell the distinctive odor of hydrogen sulfide gas rising from the earth. Earthquake swarms are common in the Clear Lake region, indicating that magma is still moving beneath the surface. These earthquakes are typically small and pose little direct danger, but they serve as a reminder that the volcanic system is very much alive. In fact, scientists estimate that a large body of molten rock, a magma chamber, exists several miles beneath the surface, slowly cooling but potentially capable of producing future eruptions. The ground itself is changing. Precise GPS measurements and satellite interferometry have detected subtle ground deformation in the Clear Lake area, suggesting that pressure is building in the volcanic system. While these changes are measured in millimeters per year, they're enough to concern volcanologists who understand that such movements can precede volcanic activity. For decades, scientists believed that volcanic threats in California were limited to the Cascade Range volcanoes like Mount Shasta and Lassen Peak. Mount Konocti and the Clear Lake Volcanic Field received relatively little attention from the general public and even from some segments of the scientific community. They were wrong to dismiss it. In recent years, the United States Geological Survey has classified Mount Konocti as a high-threat volcano based on a comprehensive assessment of its potential hazards and the population at risk. This classification puts it in the same category as some of the most dangerous volcanoes in the United States. The threats posed by the Clear Lake Volcanic Field are numerous and severe. A future eruption could produce pyroclastic flows, devastating clouds of superheated gas, ash, and rock that can travel at hundreds of miles per hour, incinerating everything in their path. The steep slopes of Mount Konocti make these flows particularly dangerous, as gravity would accelerate them toward populated areas around the base of the mountain. Lahars represent another significant threat. These volcanic mud flows form when volcanic material mixes with water from rain, melting snow, or Clear Lake itself. Lahars can travel for miles from their source, following stream valleys and inundating communities with little warning. The consistency of wet concrete, they can destroy buildings, bridges, and everything else in their path. Volcanic ash represents a more widespread threat. An eruption could blanket the region with ash, contaminating water supplies, damaging crops, causing respiratory problems, and disrupting transportation and power systems. Depending on wind patterns, ash could potentially reach the San Francisco Bay Area, affecting millions of people. The volcanic gases released during an eruption pose health hazards even without explosive activity. Carbon dioxide can accumulate in low-lying areas, displacing oxygen and causing asphyxiation. Sulfur dioxide can cause respiratory problems and contribute to acid rain that damages ecosystems and infrastructure. Perhaps most insidiously, the geothermal features that make Clear Lake a tourist destination could become deadly traps. Soda springs, near the town of Clear Lake, transform from a popular tourist attraction into what scientists now call a potential death trap. In the late 1800s and early 1900s, Soda Springs was a thriving resort destination. Visitors came to enjoy the naturally carbonated mineral waters that bubbled up from underground. Hotels and bathhouses were built to accommodate tourists seeking the therapeutic benefits of these waters. But in recent decades, the character of Soda Springs has changed dramatically. Carbon dioxide gas emissions have increased significantly, creating dangerous concentrations in the area. The gas, which is heavier than air, accumulates in depressions and enclosed spaces. Several deaths have been attributed to carbon dioxide asphyxiation in the area, including visitors who didn't understand the invisible danger lurking in what appears to be a peaceful natural setting. Today, warning signs are posted around Soda Springs, and access to some areas is restricted. But the incident serves as a stark reminder that volcanic hazards don't always announce themselves with dramatic eruptions. Sometimes the danger is silent, invisible, and insidious. The 17,000 people living in the communities around Clear Lake, including the towns of Clear Lake, Lakeport, and Kelseyville, face a unique challenge. Many residents are unaware of the volcanic threat, or they've lived with Mount Konocti as a scenic backdrop for so long that they've become complacent about the potential danger. Emergency preparedness in the region is improving, but significant challenges remain. Evacuation routes are limited, and the area's rural character means that emergency services are spread thin. A large eruption could occur with little warning, giving residents only hours or even minutes to evacuate. Scientists from the USGS and various universities maintain monitoring equipment throughout the Clear Lake Volcanic Field. Seismometers detect earthquakes that might signal magma movement. GPS stations measure ground deformation. Gas sensors sample volcanic emissions. This network provides crucial data that could offer advance warning of an impending eruption. But volcanic prediction remains an imperfect science. While monitoring can often detect precursory activity, the warning signs that an eruption might be imminent, the exact timing and magnitude of eruptions are difficult to predict. Volcanic systems can show signs of unrest for months or years without erupting, or they can erupt with little advance warning. The Clear Lake Volcanic Field exists within a broader context of California's complex geological hazards. The state is famous for its earthquake risk, with the San Andreas Fault and numerous other active faults threatening millions of people. But the volcanic threat is equally real, if less well understood, by the general public. California is home to several potentially dangerous volcanoes. Mount Shasta, a massive stratovolcano in Northern California, is considered one of the most dangerous volcanoes in the United States due to its size and proximity to populated areas. Lassen Peak, which last erupted between 1914 and 1917, demonstrated that California's volcanoes are not merely relics of the geological past, but active features that can erupt with little warning. The Long Valley Caldera, East of the Sierra Nevada is another high-threat volcanic system. This massive caldera, the depression left by a catastrophic eruption 760,000 years ago, shows ongoing signs of volcanic unrest, including earthquake swarms and ground deformation that have concerned scientists since the 1980s. What makes the Clear Lake Volcanic Field particularly concerning is the combination of volcanic threat and population exposure. While larger volcanic systems like Yellowstone capture public attention with their potential for catastrophic eruptions, the reality is that smaller volcanic systems near populated areas often pose a more immediate and realistic threat. You might wonder why we should care about a volcanic field that hasn't erupted in 11,000 years, especially when California faces so many other pressing challenges. The answer lies in understanding geological timescales and probabilities. 11,000 years seems like an impossibly long time from a human perspective. But in geological terms, it's barely a moment. Volcanic systems can remain dormant for thousands of years and then suddenly roar back to life. The ongoing volcanic activity beneath Clear Lake, the earthquakes, the ground deformation, the geothermal features, all indicate that this is not a dead system. It's a sleeping giant that could awaken. The impact of a major eruption at Clear Lake would extend far beyond the immediate area. The San Francisco Bay Area, home to more than 7 million people, is close enough that volcanic ash could disrupt the region's economy and quality of life. Agriculture in the Central Valley could be affected by ashfall. Transportation systems could be disrupted. The economic cost could run into the billions of dollars. There's also the question of lessons learned, or not learned, from volcanic disasters elsewhere. The 2018 eruption of Kilauea in Hawaii destroyed hundreds of homes and displaced thousands of people, despite the volcano being one of the most closely monitored on Earth. The eruption of Mount St. Helens in 1980 killed 57 people and caused billions of dollars in damage, fundamentally changing how scientists and emergency managers think about volcanic threats in the United States. These events demonstrate that volcanic hazards are not hypothetical concerns for some distant future. They're real threats that can materialize suddenly and with devastating consequences. The Clear Lake Volcanic Field also offers valuable opportunities for scientific research. Understanding how this volcanic system works can help scientists better predict volcanic behavior, not just in California, but around the world. The geothermal features provide insights into deep earth processes. The geological record preserved in volcanic rocks tells the story of past eruptions and climate changes. There's even potential economic benefit from the volcanic activity. The geothermal resources of the Clear Lake area could be harnessed for clean, renewable energy production. The geysers, located just south of Clear Lake, is the world's largest geothermal power complex, generating enough electricity to power a city the size of San Francisco. Expanding responsible geothermal development could contribute to California's clean energy goals while providing jobs and revenue for local communities. Mount Konocti and the Clear Lake Volcanic Field stand as reminders that California's geological dynamism, the same forces that created the state's stunning landscapes, also create serious hazards that demand respect and preparation. The volcanic field is more than just a geological curiosity or a scenic backdrop for lake recreation. It's an active volcanic system that poses real threats to real people. It's a scientific laboratory that offers insights into how our planet works. It's a challenge to emergency managers and policymakers who must balance the realities of volcanic risk with the needs and desires of communities that call this beautiful region home. As scientists continue to monitor the Clear Lake Volcanic Field, each new piece of data brings us closer to understanding this complex system. The earthquakes that rumble beneath the surface, the gases that seep from volcanic vents, the subtle movements of the ground, all tell a story of ongoing volcanic processes that could, one day, produce another eruption. The question isn't whether the Clear Lake Volcanic Field will erupt again. The question is when. And when that day comes, our level of preparation, our understanding of the threat, our emergency response plans, our public awareness, will determine whether we face a manageable crisis or a devastating catastrophe. The sleeping giant of Northern California deserves our attention, our respect, and our vigilance. Because while Mount Konocti may be dormant, it is not extinct. And in the geological blink of an eye, everything could change.